All right, so next section about multiplication rule. I'll talk about complements and conditional probability. Fun stuff here, but still multiplication rule. So we're still dealing with and problems. All right, key concepts of this. We're going to talk about probability of at least one. That's going to be an important thing. So find the probability that among several trials, we get at least one of them with a specific outcome. Probability of at least one, that's going to be a big thing. And then conditional probability, so probability of an event when we have additional information that some other event has already occurred. So a given, this has already happened, or in this case, it might be that we narrow our sample space down. Like we may have data from the entire school, but we may say, okay, find the probability that you agree with extending lunch period to 1 hour, given that you're a senior. So when your conditional probability there is saying, okay, forget everybody else's answers, only look at the senior's answers and find the probability. I would say it'd be pretty close to 100%, but only if you got to leave. All right, so at least one and conditional probability, those are the things we're going to look at. So complements is the first thing. So that's complements, not like I like your shirt. Complements more like in the terms of geometry, the other side of the coin. Like complement in angles were 90 degrees. So if I told you I ask you what's the complement of an angle that's 30 degrees, you tell me it's 60 degrees. Okay, so it's the other part. So a complement of an event is the other part. So probability of drawing a 2 of hearts is 1 out of 52. Not very good probability. Okay, the complement of drawing a 2 of hearts would be anything but a 2 of hearts, which would be 51 out of 52. The complement of that event. Okay, so the probability of drawing a heart would be 13 out of 52, or 1/4. The complement of drawing a heart would be 3/4. Things that are not hearts. Okay, so that's what complement means. So at least one is equivalent to one or more. Okay, so those words go together. So if they say one or more or at least one, that's the same thing. The complement of getting at least one item of a particular type is that you get no items. So the complement of at least one is none. Okay, and what do we remember about the probabilities of an event? All the probabilities of all the events should add up to be what? 100%, right? So if we're dealing with probability of at least one being and the complement being, excuse me, none, then we can use that complement to help us find the probability of at least one. Okay. We can find the probability that none of them occur. That's a much easier calculation than trying to find the probability of one of them occurring, 2 of them occurring, 3 of them occurring, 4 of them occurring. That sort of idea. Okay. So using the complement is going to help us here. Here's how you find the probability of at least one. The probability of at least one is take 1 minus the probability of none. That I'm putting a box around that. I'm putting stars by that. I don't know why. It might be important. It actually is the basis of this whole section. Okay, so calculate the probability of none occurring and then subtract that from 1. And that gets you the probability of at least 1. Okay. It is a very cumbersome calculation to calculate the probability of 1, 2, 3, 4, 5, 6, 7, 8, all of those things occurring. But it's much easier to say, okay, what's the probability of that not happening? Or that never happening? The probability of none. and just subtract that from 1. That's a much easier calculation out of that. So that's how we're going to find probability of at least 1. Let's look at an example. Nobody buys DVDs anymore. We all stream on Netflix or Hulu or wherever. But Top Fruit Supplies X Data DVDs are in lots of 50, and they have reported a defect rate of 0.5%. Okay, so this is a manufacturing example here. We have a defect rate of 0.5%. That's less than 1% of the DVDs we make are bad. That's pretty good, I'd say. And so the probability of a disc being defective is, and they just give me the decimal form of that 0.5%. They didn't have to do that. They did. It's nice of them. It follows that the probability of a disc being good is 99.5%, or 0.995. What is the probability of getting at least one defective disc in a lot of 50? Okay. So, what's the probability of getting at least one? So that's the key word. At least one. So that tells us we're going to do probability at least one defective would be 1 minus the probability of what? None defective. Okay. The probability that all 50 discs in a group of 50. So why quality control works, you usually don't test every single item that comes out. You pick a lot of them and you test, you get a group of them and you test them and hope that that sample applies to the population. Okay. So 1 minus all 50 discs are good or none defective. That's what it means, same thing. 1 minus what's the probability of a disc being good? 99.5%. That's what they told us in the problem. But for 50 discs, you got to raise that to the 50th power. Okay? If it were 25 discs, we'd raise it to the 25th power. If it were 10 discs, we'd raise it to the 10th power. We just chose to test 50 of them. Okay? So 0.995 raised to the 50th power. That number, 77.8% or so. And we're going to subtract that from 1. 3 significant digits would be 0.222. Yeah. Now, if you did not do this 1 minus thing and you wanted to try to calculate up probability of 1 being bad, probability of 2 being bad, probability of 3 being bad, that sort of thing, you would have to add up all of those probabilities to get there. And that is a very cumbersome calculation. That's why we need to know that formula. 1 minus the probability of none. All right, what's probability of being bad? 0.005. So the probability of 1 being bad would be 0.005 in the first power. Probability of 2 being bad would be 0.005 in the second power. 3 being bad in the third power. And you had to add all of them up. Good. Yeah, because all those are going to be tiny decimals. Right? And then you end up having to total them all up. And when you total them all up, you're going to get this same number here. It sure is easier to do 1 and subtract it from 1 than it is to do 50 of them. Because you could have a probability, you'd end up having to do the probability of all 50 of them being bad, all the way down to 1 of them being bad, and add that all up. Yes. Indeed. All right, so Conditional probability. So this is the other pillar of the section. Conditional probability of an event is a probability obtained with the additional information given. So probability of B given A, we talked about that in the last section, denotes that the conditional probability of event B occurring given that event A has already occurred. And you've got this little formula here. We didn't have to memorize very many formulas at all for the first 3 chapters. Probability, we've got to know some of them. Okay, so make yourself some note cards or some sort of formula sheet thing to help you with the probabilities, and have that handy for all your quizzes and tests. That's really best advice I can give you for that. So probability of B given A, so you're getting the probability of A and B, and then divided by probability of A. That's the formula way of doing it.
Are you saying you would let us have the formula while taking our test?
You're doing it online at home. So yeah.
It doesn't mean we automatically would.
On the final exam, I'll let you have one.
Oh, okay. Well, that training stuff. You will or won't?
Yeah, I will.
Wow. You made a lot of things. Let me eliminate mine.
All right, so here's the formula. What do we know about just the top part, probability of A and B? What could that be? It's a multiplication rule. Could A and B be dependent? Could they be independent? Could be either of those. So this part is we've still got to use the other stuff that we know for that. Okay, so don't lose the fact that, hey, probability of A and B could be dependent or independent. You got to know, which one to do there. Probability of A, that's a single event. Okay, so gotta pay close attention to this. All right, conditional events. It says the intuitive approach again. I'm not sure how intuitive it is. I think it makes sense, but you may not. Conditional probability of B given A can be found by assuming the event A has occurred and then calculating the probability that event B will occur. So that's like taking it out of the formula and doing it by looking at the data. It's kind of that's like saying the problem where I said we did a survey. What's the probability of somebody wanting to extend lunch to an hour long, given that you're a senior? That means I threw out all the data that was sophomores, or juniors, sophomores, and freshmen, and only looked at the senior data. So it can be done if you've got the information. Let's look at this example, and maybe we can figure that out. All right, so again, we're back to our drug testing. Refer to a table to find the probability that a subject actually uses drugs, given that he or she has a positive test result. Okay. 2020 rules, we could talk about coronavirus. Positive tests, false negatives, that sort of thing. False positives, all those things occur. Anytime there's a test that happens. Flu season, exact same thing. Okay, none of that is out of the question. So any of these, all these things occur anytime you have a test for any substance or sickness. All right, so here we have positive drug tests. There were 44 that were true positives, 90 that were false positives. And then the negative drug tests, there were 6 that were false negatives and 860 true negatives. That's probably a good thing. Now, what do we know about that? We want to find the probability that a subject actually uses drugs, given that he or she had a positive test result. So what does that narrow down our focus to? Only the positive tests. So where are the positive tests? The first column, the left column, right? Those are the only ones we're looking at. The negative tests don't matter in this problem because they said given that he or she had a positive test result. So that says, I don't even worry about those negative tests. Okay? So this is that intuitive approach, not using the formula. and saying, oh, well, it's 44 out of what? 134, the total of the positive tests. Now, there's that number. Where's all this junk coming from? It's coming from doing it with the formula. Wasn't it easier to just think about it that way? So maybe the formula isn't the best thing always. If you got a table, I think the intuitive approach is the best way. The formula always works. Probability of subject uses drugs and subject tests positive. So that's 44 out of the 1,000 that we have here. If you total up all those numbers, 1,000. Okay. Probability that they test positive is 134 out of 1,000. Then they divided those and we got that same number. We got to it much quicker by just narrowing our focus on the table. The intuitive approach, I think, is a little easier. If you've got a table. If they just give you the probabilities, then you have to use the formula. That's my spiel on that. If they just give you the probabilities, you got to use the formula. If they give you a table, then I say narrow your focus on that table. Much easier. Okay. Confusion of the inverse. Okay. Probability of A given B and probability of B given A are the same. It is incorrect to believe that. Or to incorrectly use one value for the other. It's called confusion of the inverse. A given B is not the same as B given A. That's what this means. Okay? It seems like it doesn't have to be said, but it's very often confused. A given B does not match B given A in all cases. Okay, that's the probability of A given B does not equal probability of B given A. All right, easy stuff. This is not a very difficult section with the multiplication rule. Big things to take away are probability of at least one is 1 minus probability of none. Make sure you know that. That's you're gonna need that. And then think about the intuitive approach. Versus the formula, probability A and B over probability of A. That sort of thing. So make sure you pay attention to those things.